Let's take a look at number 5 here in section 5.4. We're going to use the fundamental theorem of calculus part 1 to find the area of the region under the graph of this function on this interval. So just taking a look at the graph of the function 2x squared. Here's the graph of 2x squared. All right, at 0, it's 0. At 1, it's 2. And at 2, if I plug in 2 here, I'll get 4 times 2, I'll get 8. It's just a parabola opening upward like this. Of course, on the interval from 0 to 2, I've shaded in red the area we're looking for. So this is the area we want to find. And so how do we find that? Well, remember, the definite integral from 0 to 2 of this function will indeed give us the area under this curve, and of course above the x-axis, right? This area that's trapped between those two curves on the interval from 0 to 2. So as far as the calculation goes, it's pretty easy. Remember the fundamental theorem of calculus part 1. We're going to find the antiderivative of 2x squared, which is, 2/3 x cubed. All right, so it's 2 times x cubed over 3, or 2/3 x cubed. Always when you find the antiderivative, it might be helpful just to think about, well, if I take the derivative of this, what do I get? And just double check and make sure you're back with where you started from. Helps you to keep from making those little mistakes. So again, we're going to use the evaluation bar. We're going to evaluate this antiderivative at the upper limit of 2, at the lower limit of 0, and then we're going to subtract. I'll go ahead and just factor this 2/3 out. And so we'll look at x cubed, where x is 2, minus 0 cubed, which is 0. 2 cubed being 8, this becomes 8 times 2/3, or 16/3. But that represents the number of square units under this curve. This shaded in area has an area of 16/3 square units. Okay, I hope this is helpful.